So, but stage math, it's written in mathematics. So when you see these things, you know. You're not practically ready to say what does, most of the key terms there. Okay, override. Good. So most of the key terms there are already, you are able to remember them. So here, what do I want to do? A pie chart. Okay, so for the pie chart, I have my pie chart. Are you seeing it? So that's what I have here. And another thing again is what? Histogram. So all you need to do is just to call, it's called hist here. So you just call it, and then you run it, and you have your histogram. So these things are there, and we have to use them. Now you're talking about, is stage math better than R? I like using R and all that. See, you use it for what? Mean, for summary statistics. Are we listening? So all you need to do, just say, what are you looking for? For the mean, this is a method. The standard deviation, this is a method, right? The correlation is there. And then the summary statistics is there. So first of all, since I am giving them labels, I start with the fourth one, the mean. So I want the mean, because here I'm working with, I have the mean for X, that is date, and the mean for Y. I'm just using different types, the standard deviation for Y. So the first one, which is the mean, you can see the mean here, okay? Then I'm looking for the standard deviation of the price. Remember that my data has what? Price, date, and what? Price. It could be like the data we looked at this morning, which is maybe opening price, closing price, high price, low price. So you want to pick one and say, what's the mean? So you can just use this easily, okay, to solve it. So this is the mean, and if I want the standard deviation, I have the standard deviation, right? And then if I want the summary statistics that is well known for R, you can see it. The count for each of the column, right? The mean for each of them, date, price, the standard deviation, the minimum, and then all these quantiles, okay? And then the marks.
For the case of the mean there, you're putting date. Are you getting mean for the date?
It's just, I just put values there. I just decided to name it date. Yes, that's why I'm telling you that it could be the financial data. This is just a data I'm playing around with, but it has labels. So it could be the financial data we downloaded that has what? Opening price. It has high price, low price, closing price. So instead of date here, if she's going to do it with her system, instead of date, she will put what? High or low or opening or closing. Do you understand? So but this is just for you to know how to do it. So for that data that we have, when you say summary statistics, 6 columns, I think, and it will give you the summary statistics. You asked me that. Tapa, you asked me about R. Some things that, I said these are things that we can do in R, right? So it will give you all those things. Okay, so this is another way for getting data and all that. You can list it out, you can play around with it. So you have many ways of getting data into your system. Now, another beautiful way is if you have the URL that we have the data, you can copy it and put it there. It will read it straight from an online. So these are very many methods of loading data into your system. It could be COVID data, it could be different kinds of data. Whether you're working in biomathematics or you're working in mathematical modeling or you're looking at financial mathematics or statistics, you know, you want to get the population of a particular country and play around with it, you can do all those things. You can pick directly from online because we have some places that we get, we have what we call the public data where you can get, we have to give permissions. Okay, so because another thing. So who knows what this is? She taught us. Oh my, that's great. So I have to keep it here because I want to remember. And I tried it and I also got the data. So you go to, when you want to get data from online, this is what you do, right? You know, and you select all those things and then you have it. So that is something that you must make sure you learn. Okay. Okay, what are these ones now? We're just playing around with data here. Okay, so you also asked about linear regression. You can look at the, you know, this is the model for linear regression, right? So you can do that. And then you call it. So you remember always to call it. I hope it will run. So you call it, paste it, and I run it. So what it's giving me is the model, because I've not even added anything to it. You know, no data, no values for A, no values for B, and so on. But this is all these ones are also plots of different things. But we can't look at plot now because we've done that severally. Okay. So and I've already dropped some books on plots for us at Zulip, so we can check it out. So these are, this is the normal way to download data. This is where I'm going to. You could download this data right from online. It's there. Are you seeing this? I just copied the address online, and I pasted there and asked it to bring it out for me, and it will bring it out. The time for which for these things to come out depends on our internet connection and then our kind of system. But for this one, we know already that it's because of our internet connection. But it will go there and bring the data for you. You can copy this and try it yourself. So it brought this data directly from online. I don't have it. So this is this data here. So I think we have talked so much about you trying to import data, trying to play around with it, and do a lot of things with it. This one too, I uploaded this one from online. So you can upload this from online too. Now, I want us to quickly, I know I'm not fast, I'm just taking my time to go through it. Okay, like this data we have, you can do the basics, all the basic statistics that we've done this before. You can do all that, and then you can show different plots. We've done all these plots before: histogram, scatter plots, and different things. You can do all of them. We've done that before. The correlation, you can also calculate it. You can bring out the correlation matrix, and you can use SageMath to do these things. Now, stochastic differential equation. Okay. So this is a general stochastic, a very simple stochastic differential equation that she used today. We want to see how we can use it for some things. And this is the first one, okay? The simulation of stochastic differential equation, which she's going to do for us. I had it here since, but I was waiting to see what she would bring, and she brought something very beautiful for us, okay? So here, this is the first time you are seeing it. As in the first time we are presenting it here, and that's why I decided to break it down. Now, if you look at this stochastic differential equation, you have mu, look at the variables. Are you seeing the variables? Mu and sigma, okay? So see them here, you define the parameters. So this is mu, this is sigma, and this is the initial value of the stock price, which is x naught. And then you have time, you have the number of steps, and you have change in time, which is of course going to be t over n. Then, this is how you use, this is what you use, the W of t, this is what you use to generate the Brownian increments. Look at this part of it. We're looking at this part now. Okay? That is where we have the noise. And this is what you use to generate it. Here, you are initializing the process. Okay? And then, this is the equation. We have discretized it, right? Are you seeing that it has been discretized? This is change in x, isn't it? This and this will have the change in x. Then this is your mu, right? And then this is sigma. So this is a discretized form of that ODE the SDE that we just looked at now. And then you plot the simulated part, which you just did, and then label it to be what? Simulation of stochastic differential equation. And this is it. Like she told us in the morning, since it is randomly generated, this will not come up the same way. See the way it is. Then when you roll it again, it comes in another way. But this is an excellent demonstration of the part of a Banner motion, or of a geometric Banner motion. So that's what we have here. So here we're just talking about stochastic differential equations, and then how we use them further. Here also is the same thing, okay? But what we have here is also the discretized SDE. In fact, this is the solution of the SDE. That's what you have here. And then if you simulate it, you also get the same thing. And here, like I was asking her to do, I said, can you tell us the predicted price for a particular day or year or something? So that's what we did here, the future price. So the predicted price after 1 year is going to be what? 122. Do you get it? So you have to tell it to do that. What are you starting with? S0, that's the initial stock price, it's 100 naira, right? S0 is 100 naira. So you now ask it for the future price. So this is the formula for the future price. So it will simulate the part and also tell you what it will be in 1 year.
Excuse me.
Yeah. I know she's going to ask. I'm already giving her an assignment, so let me close it. Okay.
So if I need to predict the stock price, for example, tomorrow, do I need just the closing price of today, or I need to predict like for all those years, those days including today to get the one of tomorrow?
No, you see, you have to choose one. And most times, of course, you know the closing price and the opening price, they're the same. So it's better you start with the opening price. Because the high and the low has a kind of variation that you cannot depend on. You cannot even tell when it will be high during the day. It's not known.
Like which one is better if I
Open! Use the opening.
Predict the closing price of tomorrow.
Yeah, you use for tomorrow.
Have daily closing prices of the previous.
See, you start with a closing price for today. You want to predict the one for tomorrow. So it's the one for today you will use for your simulation to get the one for tomorrow. Yes. Don't you understand?
Yes. But I'm saying, is it okay to have all the
values
using the previous days? I know it is a Markov process.
Yeah.
But is it okay to predict using the previous maybe 100 days, including the one of today, to have the one of tomorrow? Or it doesn't?
You can use it.
Like, is it better than just using the one of today and having the one of tomorrow?
It's not, you see, because the one of yesterday will not really give you anything serious. But we are talking about, maybe you are saying since it's a Markov process, so it does not depend, the history is not important. It's the one it's just like the drunkard we are talking about. That's what she's asking us. Remember the drunkard's walk? That's what she's saying. That's the Markov process, isn't it? So it doesn't matter how the drunkard is coming from here, right? And then he gets to this place. The next step he's going to take, does it depend on where he started from? No.
But then,
What does it depend on? The one where he is. That's the Markov process we're talking about, right? So now she's now saying that when we want to predict this value, so you have to use the other years. I don't want to show you because I said they're going to do it. So let's keep it until she has tried her best. Then we can now bring it out. She's trying to trick me into getting the solution to her problem. So let's not give it to her, right? So I've covered it. We are not seeing it again. I've covered it. Okay, she's almost there. So let's all of us help her get there. So I'll explain it to you. Okay, so there are times that you're working with data and you have missing values. Even online, you have some missing values, right? So you can bring them, you can deal with them using these codes. You can and then fill in the missing values. You can fill in the missing values. Now these things are really, really important because when you are dealing with big data, you can't go to your Excel sheet and be looking for it one. Even your eyes, even if you use Google like I'm using, you will still miss some. So let's Sage Master to find those values and fill it up for you. So it makes life easy for you. So these are the things that you can do. And then when you are going into, I thought we were going to look at machine learning, but it's not possible. But when you are going to machine learning and you are looking at training data sets, how do you split those data sets? So these are some things that Sage Math will help you do. But it's a pity that we cannot go into machine learning. But it was part of what I felt we could look at. Okay, so Sage Math have gone far in making sure that these things are settled. So you have different ways of doing these things. Okay, so now I want us to get to something else. Okay, quickly, we don't have time. So I'm thinking of what we should do. This is also simple, something simple that simulating rolling a six-sided dice, okay? So know the values that you get. It's just a simple, but we don't have time to look at it. So let's go into for population. This is a simple, a very, very simple code that will talk about if you have data and you want to know in a population how many are healthy, how many are infected, how many are recovered. You can use this code to quickly bring them out. But it's a pity we can't go into all of that. Now, there's something else I want to show you because we don't have time and I want us to focus on our project. There's this is data. So where did I keep it? Okay, is it insert? There's something I'm looking for that we should know. It's not here. Is it here? Is it here? Let me see. Actually, this was the project I thought we were going to look at initially. I told us before that we want to look at analyzing the impact of mass awareness on the prevalence of anemia for children under 5. So the first thing you do for such models is to make assumptions. So they call it the SAT model. And for the SAT model, you have the following compartments. It's just like your SIR, but this is a bit different. Okay, here is the same thing as this one, which is susceptible. And here we now be, instead of infected, they say what? Affected. And here, instead of recovery, what is this? Treated. So you have this going like this, you have this going like this. And then you have to tell yourself that maybe you assume, because when you start models like this, you have to give some assumptions. And then maybe you assume that the population is actually at the beginning. Now we're talking about anemia in children. So all the children are what? Susceptible. Until after test, before you can know that this one is there, this one is not there. Now, this might be going to this place with this rate, right? And this might be going to this place with this rate. Let me put it lambda. And then something else will happen. In this case, we are looking at when there is campaign. How does campaigning affect each of these compartments? Okay, if people have people campaign a lot about it, will the affected rate increase or will the treated rate increase? That's what we want to look at. And with all these, different things can happen. You can see how make it very complicated by adding more legs. They can live here through different means also. So I was looking at you doing this, a very simple one, and then bringing out the ODEs from this place. This is the situation at time. See, what happens after a time difference? This will now be equal to, this is what it was before, if we assume that that is the total population. But something is leaving it, isn't it, with this rate? So this will be what? Minus what? Lambda S is leaving it. Then we now look at the next compartment. So what happens after time? See, something is coming in, right? And this is what? Right? And then something is going out. And this is lambda what? I. Then you a small t. And what is happening here? Something is coming in from here. So this is what? A lambda. Okay? Except if something else is happening, then, or maybe go from treated back, because something will happen here, you go from treated back to this place. Then maybe you add something here. So what we're looking at where you just define the function in SageMath that will bring the compartment, bring the equations, solve the equations, and look at sensitivity analysis. See, you make assumptions, you formulate the model from the assumptions, the compartments. You derive the equations and represent the model in a matrix form. Now this is a system of ODEs, right? So since it's a system of ODEs, you can put it in matrix form, isn't it? So you can do that. Put it in matrix form. So that's what we're saying there. Then you obtain the equilibrium point. Most times, what is the equilibrium point? Eh?
The difference is equal to 0.
Where was it? Eh?
The stationary point.
Stationary points. We call it stationary points also. At a long time, when it's independent of time, what happens to the system? After a very long as t tends to where? When the system is independent of time. That is after how many so many years, you now discover that you always have this number of people susceptible, this number of people affected, this number of people treated. That's the equilibrium. So here we're looking for what? S naught. You'll be looking for what? A naught. And what? I naught. Then you now find the sensitivity index for the parameters. There's a formula for finding the sensitivity index. And then you now do the simulations and visualizations to show the impact of mass awareness. Okay, so you want to find out how it will be like. And can you ask SageMath to just bring that in one statement? I want you to bring all these things up. It's very possible. So you start with defining the variables. I don't want to show it to you because I feel it's going to be your work. And you do all those things, you bring it out, and then you're going step by step, you know. You're just walking and you're saying, how am I going to do these things? So this is like what we just talked about. Then you give definitions of these things, the parameters. And then you try to, this is just a simulation of the relationship. This is substitutable. Here I use the SRR because it's the simplest. Okay? Some people are doing cheating. Okay, we do. So we was to be proved because of some people. So all these things you see, these errors, I was playing around with it, trying to see if I can achieve it myself. So that's why I see a lot of errors here, and a lot of things happening because I was just doing try and error. I wanted to bring these things out. And gradually I was getting close to it. Yeah. I was just playing around with it, and this is the first compartment I got. I was saying, no. Normally you don't write compartment like this, right? So I now started looking for what to do. I said it could come like this, but I don't want to do it. I don't want the axis. So I went ahead, and it came out like this. I was still playing around with it. And then I had this, and I said, B, I want the B up here, not B in front. So we were still doing this. Then I was able to put susceptible, infected, and recovered on it. So we're going, this B is still here, I'm not comfortable with it. So I was still playing. Finally, I was able to put it on top of the arrow, like this one. I was still playing around with it, and it was now looking better. And then finally I said, okay, can you bring all these things for me out in one, and this is it. So he said, this is the SIR compartment diagram, this is it here, and this is the simulation of the model, where of course you have the one that is what? Susceptible, the one that is infected, and the one that is recovered. You can now begin to play around with it, do the sensitivity analysis. Here, there's no awareness. But when you are doing the one we talked about, of course, you have to put in that awareness parameter. It has to come in somewhere. It will be a bit complicated, but it will be very beautiful. And this will be nice. Okay. Okay, so I will not show it to you until we walk. There's something else I want to show you because I want us to quickly go into our project, okay? I don't know where I kept it. Let me look for it. Because, where is it? Is it here? Because when you are programming, you cannot be, you have to, yeah, I think it's here. You cannot be too perfect. You have to learn things every day. Like I learned some things when I got here from you, and then you learn also from others. So here, we're just looking at Monte Carlo simulation of data. And then we did a portfolio return simulation, a very simple portfolio return simulation, okay? That will bring some things. And then we did this one for stock price simulation. So the first thing you do is to calculate the mean, generate the random returns, and then you calculate the cumulative product of the returns, and then you have the stock parts. That's how you do that. Now, this is another beautiful project, the European option pricing, with two methods. Either you're pricing it with the Black-Scholes formula, or you're using the binomial option pricing method. So first of all, this is the formula for the call price. In our master's class, you should be able to prove this. So, and these are all the terms, all these parameters that you have. This is the call, stock price, this is the probability, and then you have the strike price, you have time, you have interest rate, and then you have the other one. And this is how they are related. If you use what we call the call put parity, you'll be able to get the put price, right? Financial maths. I'm talking to her. Okay, so when you use the call put parity, you have this one. So for the binomial model, this is how it works. Now the next thing is, can we price them? So we just install some libraries from, we import some libraries from SageMath, from Python, and then we use them. We define the first function, which is the Black-Scholes European option. And what are the parameters? The stock price, the strike price, time, the interest rate, volatility, and the type of option. Is it a call option or a put option? And then we have D1. Already I told you what D1 is. And we have D2, right? Then we have a control structure. And we're saying that if the option is called, this is the price, right? Else, if the option is put, this is the price. So that is why we took our time to look at the control structures. Because we know we are going to use them. The loops and for and wild and if and if else and all that. So that when it's time for real projects, we can use all those tools. So finally we say what? Return price. Now that is when you are using the Black-Scholes model. But if you are using the binomial, you still have to define how these things work. I know already that for the binomial pricing option, we try to do something like this. We say that we start here, this is the stock price, is binomial. Only two things can happen in future. So tomorrow is either the stock price, we go up by this ratio, or it will go down by this ratio. Only two things can happen. And then for each of them, as we keep going, they keep going up. So that's what we use. And that's what we use to price the option, depending on the kind of option. If it's a European option or if it's an American option. So you need to have that background, and then you can now bring out your model for the binomial. And then you put values for the option parameters. And the next thing you need to do is to call those things and put values. Once you call them and you now tell, this is just to tell you, how do I want the output to be like? And when you do that, when you run it, it will now bring out the result. European call option price, Black-Scholes, is equal to what? 10. European put option price, Black-Scholes, is equal to what? 5. That's to tell you that you have to think about errors, because it's 10 and 5. And we're talking about money here.
Dollars.
So you have to use the right pricing model. So this one is for the call and the put when you use the binomial. You can see. So that's why people are still working on getting a good model for pricing of options. Well, this one, what are we doing here? Okay, we want to stimulate the stock price using the Black-Scholes model. So when you do that, it's close to what she did. Wow, what is happening? Something is wrong here. Why should you say you don't recognize this? Okay, let me bring it out. I hope that's the only problem. So here is it. Okay? So and every time you bring it out, it will be random. Okay? So this is the simulation and then the trading days. So I don't know. I think we have covered a lot during this week. I don't know if we didn't have enough time. Okay? So, but from the foundation, I always believe in making sure your foundation is sure. So you can build on it. You can do beautiful things, you can tweak it. Okay? So quickly, let's call the PDE group to come and show us what they've done. PDE group, I want to see what you have done. So I will now vote whether we are going to present it tomorrow or we are going to follow the financial mathematician. That hopefully with the connection she's making, she will start her PhD in Europe soon. Justin, we're waiting for you. Does anybody else have any other projects? That, oh, I've been here for this number of days and I want to do this thing, no matter how small it is. I was thinking you would give us something.
Yes, in the epidemiology, they have that SIR. That is his field.
Really?
Yeah.
I hope we didn't make any mistake.
Actually, wanted to give us a
Okay, so I want the PD to come and give us something they've done. And then, can you not try to do something simple from what you've done? No. Is it Windows? It's not Windows, it's like yours. Maybe it's helping.
I have also
Installed it. Bring it, let's have a look at it first. So PD group are waiting for you. Are we here? Are you looking for something? How are you? We missed you in the morning. How is she now? Okay. She's better? Okay. Come and sit here and all her team members should be behind her to help her. Come and sit here. Come and sit here. Then you charge your phone, your system there. Let's see what she wants to present to us. Okay. Right now, I'm not sure if anything has been done on PD for SageMath. So that's a challenge to us, okay? So do something and then share it with our presenter for the lady that presented yesterday, and she will help you with it.
Okay. I managed to come across one simple example
Okay.
of a partial differential equation. It's only one equation. I've not tried out with a system of partial differential equations. So for the meantime, we can adopt this as our working example of a function whose partial differential equation we want to get. So this is our function, a function of x and y. So we started by defining the variables x, y, z, and t. We hope to use them in plotting the z and t. Okay. Here I was reminding you of what we did in differentiating functions. So I tried differentiating the function for xy exponential negative x squared minus y squared with respect to x. This is the first bracket.
Yeah.
I'm differentiating the function with respect to x. So this is what we get. Now the next step is to have a partial differential equation to differentiate that one equation of ours with respect to x and also with respect to y at the same time. So that is what we are going to see next. So this is what we do. You see, previously here we had only this x to mean we are differentiating with respect to x alone. But now we expected to get a partial differential equation. So we differentiate with respect to both x and y at the same time. This is the only difference. So this is the PDE now we get, which we call G in the next line. And what follows next is the graph of our partial differential equation. So this is the plot for G. G is the partial, this is our partial differential equation. We called it G, and now here we are plotting it. We set x to run from negative 2 to positive 2 and also y from negative 2 to positive 2.
That's a U10. What is it?
Yes, opacity. We tried as a group to search for it and we said object not known.
What?
Object not found.
Why is she laughing? Why is she laughing? Are you sure? Are you sure you are? Are you sure? Are you sure you are obeying the rules? And the rule is that you should make Google your friend.
Yes. Okay, I take it back. So that is the plot of our partial differential equation.
Yes, there.
Okay. Okay. But remember, this side is for opacity. Here in said math, there is no opacity.
Opacity.
Opacity. So the PDE group, that's what we managed to prepare for today's presentation. As simple as that. Sorry, it's been so brief because of the time constraint.
That is not a project. I reject. I don't accept that as a project, please.
Sorry.
No.
Something else.
So who wants to join him for SIR model?
SIR model.
SIR model, yes. Who wants to join him?
Yeah, you come with a computer with Panda.
No, for us as Panda,
But really is as
Hmm?
this one has no pandas and we don't have a
So why don't you do something without data? You don't need. Do something without data.
This one. I think it is.
Were you able
It's
to?
no sage.
Oh, no sage.
He has no sage.
Oh.
So I don't.
Oh, okay.
If it was,
Just
if
read
it
the
is,
button.
I really want to give you.
just import and it comes with
I really want us to have two projects. So
so you work with them.
yes,
So now, right now, we work on our project.
yeah.
I'm working with
You cannot work alone. You can help, Abby. Everybody will help. Now, which group will join the SIR? Josephine, are you there?
Yes, that's
Okay, please start. Let's start work. SIR model. Let's start work. Look at what you are doing. Look at what you are going to do. Look at what we are following. Now, maybe we just, instead of looking at this one that's a bit complex, let's look at just SIR. Let's forget about the SAT. So let's look at SIR. Make your assumptions. Since he's into biomass, so it's easy for him to make those assumptions, right? You can make it as simple as you like because you're just starting. Then later on, you can make the reduce, make it restricted kind of. So then you formulate the model from the assumptions. Then you want to see the compartments. Then after that, we want to see you bring out the equations, derive the equations, and then represent the model in the matrix form. And then let's see how far you can go with this step. Meanwhile, the financial maths group should now quickly start from the beginning and start looking at some things again. We're all going to help. Everybody will help. Everybody will help. But let's take this time now for our project. Everybody will help. Quick, let's walk. Two groups. I'm looking at two groups here. So use all that you have gained and then ask your friend. Who is your friend? Google. And then you can ask, as we're here, you can discuss, you can talk about it if you run into any problem. Well, I really want you to see, I want to see you use what we have done. Which is your group? Anyway, let's see how it goes. Okay. Are you going to be on this tour?
Yes?
You're going to be on this tour.
Two?
Are you going to be filming it tour?
I think I will just be getting it. Are you done presenting?
Yeah. This is time for project.
Just capture them for a few moments.
Everybody come up so that he can. You can. Well, no, I think continue, be together, be doing your work, continue your work. Continue your work. I think you should help them, you should join them. So, are we all in agreement? You have 8 things to give to us. So let's start. Okay, and everybody contribute. It's a simple model, SIR. So first of all, you go to where? Mark down your assumptions. List them out. Then you type the. So just tell yourself, when you start the project, tell yourself, what do I want to do, right? Then what steps will I take to do what I want to do? So write down the steps and then see how you can walk through it step by step. Let's work hard. Send your person, I also look at it. Okay. This math something. Check. Maths, we have internet, so check.